Hello and welcome to another one of these ADD videos. Today we're going to look at the concept of a substrate saturation curve. This thing right here. Alright. As you can see, it's substrate concentration on the x-axis, reaction rate on the y-axis, or velocity, whatever you want to call that. So basically what we're doing is we're looking at the interaction between a substrate and an enzyme. This is the active site of the enzyme. This is where the substrate binds to the enzyme like a lock and a key, right? The substrate would be the key and the enzyme would be the lock. And it's a specific matchup. Only certain substrates fit into certain enzymes. They form this transition state here called an enzyme-substrate complex. And it can either dissociate by going back to the initial reactants of substrate and enzyme, or it can undergo the desired transformation into a product, and the enzyme will just go back to its native state, wait for another substrate. Okay? So when we're looking at this interaction and we start to increase the x-axis concentration, the substrate concentration, what we get is this hyperbolic shape. Okay? If we see something like this is called a sigmoidal shape, and that's showing you that there's some cooperativity occurring. That's a whole different topic of its own, and we'll discuss that later. So initially, at low concentrations of substrate, because there's an abundance of enzymes and little substrate concentration, relatively speaking, then it obeys first order kinetics. The reaction obeys first order kinetics and looks pretty linear. But as you start to increase the substrate concentration, you start to fill up all the enzymes, and what happens is you get this tapering off effect here. It starts to go off to the Vmax limit. So has free access to enzymes due to the enzyme concentration being larger than substrate concentration. Oops, sorry about that. And then as the substrate concentration increases, the enzymes become bound. So what has to happen is substrates have to wait for an enzyme to free up. So that's why the reaction starts to slow down or taper off. And eventually, when we get to high enough concentrations of the substrate, you can see that it starts asymptotically approaching some Vmax value. And what's happening here is that the enzymes are completely saturated, and the substrates have to wait until one frees up, just like earlier, but they're all completely saturated. And now the reaction becomes completely independent of the substrate. Okay, independent, doesn't care. So it obeys zero order kinetics on the second half. All right. So I hope I've cleared up any confusion that you might have over the substrate saturation curve. We will talk about the significance of Km and half Vmax here on the Michaelis-Menten video. So for now, just know what this is. Know what the difference between hyperbolic and sigmoidal is, and go on to the Michaelis-Menten kinetics enzyme videos. All right. I hope I've cleared up any confusion you might have. Thank you and have a nice day.